everyone, welcome back. So imagine for a second you're looking at a map, right? But this isn't just any map. It's so incredibly detailed that you can zoom in and see every single house, every little tree, everything. Now swap out those houses for stars, and you've got a pretty good idea of what the Euclid Space Telescope just did for the very center of our galaxy. It's truly mind-blowing. These aren't just any old pictures, friends. We're talking about the biggest, most incredibly detailed visible light photos of our galactic core ever taken. And when I say big, I mean big. We're talking 6 gigapixels. To put that in perspective, that's like stacking over 20 full moons across the sky. Can you even imagine? In just one of these images, there are more than 60 million individual stars. 60 million! Plus, you can see all these gorgeous nebulae. Those are just pretty gas clouds, kind of like cosmic cotton candy. And dense star clusters, along with dark, mysterious dust clouds, where new stars are actually being born right now. It's like Euclid just pulled back a giant curtain on that faint band of light we call the Milky Way. It's showing us, in astonishing detail, just how incredibly packed it is with stars, with gas, and with dust. It's truly astonishing. Now here's a fun twist about Euclid. It wasn't even built to stare at our own galaxy. Seriously, its main job is to hunt for dark matter and dark energy. These are like the universe's invisible ingredients. We know they're out there because of how they affect things, but we can't actually see them. Euclid usually looks at super distant galaxies, trying to understand what this mysterious stuff is all about. But for one special day, Euclid took a little detour. It pointed its super sharp eyes right at home, specifically at the very center of our own Milky Way galaxy. That's where stars are crammed together, tighter than pretty much anywhere else. Imagine a city where every building is a star. The galactic center is like the busiest downtown intersection you can imagine. It was kind of like a quick pit stop for Euclid. It spent 26 hours observing over 9 different times last March. All those separate snapshots were then stitched together to create that one massive, breathtaking image we just talked about. And here's a mind-blowing detail. Euclid's camera, the one that sees invisible light, is incredibly sharp, just like the famous Hubble Space Telescope. But get this, it can see an area of the sky 270 times wider than Hubble. Think about that for a second. To capture that same incredibly wide and detailed view from Earth, it would take a telescope thousands of hours of observation. Euclid just zipped it up in a day. Pretty wild, right? Now, here's where these amazing Euclid images become super important for another space mission. Think of it like this. These incredible pictures are actually a crucial warm-up act, a scout mission, if you will, for a different upcoming space telescope. It's called the Nancy Grace Roman Space Telescope, and it's going to be hunting for exoplanets, which are just planets outside our own solar system. And it uses a really clever trick called gravitational lensing. Imagine a planet's gravity is like a little magnifying glass. As that planet passes in front of a faraway star, its gravity ever so slightly warps the space around it and bends the light from that background star. We see that bending light as a subtle brightening or flickering of the star. It's a tiny, tiny effect, but it's enough to tell us there's a planet there. So here's where Euclid comes in. Its images are like a super detailed before picture. They precisely map out the exact positions of millions of background stars in the galactic center. Later, when Roman spots that subtle flicker from a star, that gravitational lensing signature, astronomers can compare it to Euclid's map. This lets them confirm, yep, an exoplanet definitely caused that light bend. This whole technique is especially useful in places where stars are packed super tight, like our galactic center. Why? Well, more stars mean more chances to spot these elusive exoplanets. It's like having a bigger pond to fish in. And get this, Euclid's image already contains 51 known exoplanet systems. How cool is that? Okay, so here's where things get really wild. Deep within our galaxy's bulge, that big, thick part in the middle, kind of like the really dense central hub of our galaxy, there's this incredible star cluster called Terzan 5. Now, usually star clusters like this, what we call globular clusters, are pretty predictable. Think of them like ancient, fossilized cities of stars. They're typically super old, around 10 to 13 billion years old, and all the stars in them were born at roughly the same time, from one giant cloud of gas. It's like a big family all born in the same year. But recent observations, especially from the amazing James Webb Space Telescope, are really hinting that Terzan 5 is anything but ordinary. It's like you're exploring some ancient Roman ruins, and then boom, you suddenly stumble upon a modern skyscraper right in the middle of it. It just doesn't fit the usual picture. Terzan 5 is also incredibly massive, weighing over 2 million times the mass of our Sun. And here's another really interesting clue. It's packed full of millisecond pulsars. These are incredibly fast-spinning dead stars, literally rotating hundreds of times per second. Finding so many of these usually signals a lot of stellar collisions and really intense activity, which again isn't what you'd expect from a quiet, ancient globular cluster. Okay, so here's where things get really wild with Terzan 5. The real bombshell dropped when scientists started looking at something they call metal content in its stars. Now, for astronomers, metals don't just mean iron or gold, it's actually anything heavier than hydrogen and helium. These are the two lightest elements, and they were basically all that was around after the Big Bang. Heavier elements, the metals, get cooked up inside stars and then spread around when those stars explode. Normally, in a typical globular cluster, all the stars are pretty similar in their metal content. It makes sense, right? If they all formed at the same time from the same cloud of gas, they should have the same ingredients. But in Terzan 5, it's all over the place. We're talking a huge range of metal content, which is a massive clue that these stars weren't all born at the same time. It's like finding people from completely different centuries all living in the same neighborhood at once. Super weird. How did they figure this out? Well, thanks to the James Webb Space Telescope's amazing infrared vision, which can peer right through all that cosmic dust, and Hubble's long-term observations tracking how stars move, scientists could put together the most perfect color magnitude diagram of Terzan 5 ever. Think of this diagram like a family tree for stars, where their brightness and color tell you a lot about their age and stage of life. And what they found was truly astonishing. Terzan 5 isn't just 2 generations of stars, which would already be unusual, but at least 4 distinct generations. These stars were born at wildly different times, some 12.5 billion years ago, others 4.7 billion, then 3.8 billion, and possibly even some as recently as 2.5 billion years ago. This just doesn't happen in a typical globular cluster, where the gas for new stars usually gets blown away after the first big star explosions. It's like the gas hung around for billions of years, just waiting to make new stars. So, what does all this wild stuff about Terzan 5 actually mean for our galaxy? Well, astronomers have a super cool idea. They think Terzan 5 isn't just a weird star cluster. Instead, it might be what they call a bulge fossil fragment. Imagine finding a leftover building block from when a huge city was first constructed. That's kind of like Terzan 5. It's like a piece from the very beginning of our galaxy's central bulge. You see, our galaxy's central bulge probably didn't just form as one big, smooth blob. Instead, it likely came together from many enormous clumps of gas and stars all colliding and merging over billions of years. Terzan 5, with its multiple star generations and incredible density, could be one of those original clumps that just never fully merged with the rest. Its orbit also tells us a lot. It stays really tightly bound to the galactic center, which hints that it was always an inside job, born right there within our galaxy, not just some random visitor from far away that happened to swing by. And remember those super fast spinning dead stars, the millisecond pulsars? The fact that Terzan 5 has so many of them totally makes sense if it started out as a super dense, supermassive clump. That kind of strong gravity would have allowed tons of big stars to form, explode, and then collide to create all those rapidly spinning stellar remnants. So, while Euclid gives us this breathtaking snapshot of our galaxy's core today, showing us millions upon millions of stars, if we zoom in even closer, we uncover these ancient secrets. Things like Terzan 5 are truly pieces of the puzzle, showing us how our magnificent Milky Way was actually built, billions of years ago. It's just amazing how the oldest secrets can sometimes be hidden right in front of us.